So that led to the notion of a general purpose, programmable device. It was only on paper in mathematics. It was an abstract concept, but it inspired a lot of people, including Turing, that such a device could actually be built. I mean, could actually be engineered, and it would work because it logically made sense because it was math that Turing had invented. So the book, this little extra course that I'll do as part of theory of computation, here's the book that I've chosen. And it's a very popular little book. It's been in print for decades, and it's just simply called Gödel's proof, meaning the proof of Gödel's famous incompleteness theorem. I talked a bit about that before. And it's written by two authors, Nagel and Neumann. Here it is. Okay, so teaching this will serve two purposes. One, it'll get me more on top of this field that I've been putting off for years. I promise one day I really want to understand Gödel. And so now I'm retired. Now's the time. So this will motivate me strongly to learn it. So when you have to teach it, that's the best way of learning something, because it is just so motivating. And no, I don't have it with me. I will do Gödel's theorem at M2 level as well. Oh, by the way, this text is I would say senior, possibly early M1. Probably a smart senior level, let's say. And I will do full Gödel at M2 level as part of mathematical logic stroke computability theory, fairly advanced. So say M2. So that's planned as well. I'll do that. All right. So expect that. I'm not quite sure when. Sometime in the middle of the course, I guess. Thinking about it, real time. Maybe a good time would be at the end. Now, this course has three parts. First part is on languages, automaton languages, I think. Second part is on computability, and the third part is on complexity. Complexity is basically a discussion of how difficult it is to compute certain things. Second part is whether you can compute at all, so if something's just not computable. Okay? So I think at the end of that second part on computability, that would probably be a sensible time to do it. So this sort of mini course that's inserted on Gödel's incompleteness theorem at a sort of senior level, I guess, senior M1, and more or less the same level as this course. How long would it be? It's 120 pages, so I don't know. A lot of words though, it's pretty wordy, so I could probably condense it quite a lot. I don't know, my guess would be maybe a month, something like that. So, expect that. So, my opinion is that any mathematically minded, educated person should know about Gödel. It's just part of the, an educated, mathematically oriented person. It should be just part of their educational culture. Right? Why? Because Gödel is fundamental to it's one of the pillars, intellectual pillars of the 20th century. So, right. Okay, now back to the nitty-gritty. You saw this particular finite state machine or automaton, same thing. 3 states, right? So finite number, therefore definitely a finite state machine. And we labelled it M1, like it's our first example of a machine, an automatic machine or automaton, right? And we input to this automaton a binary string, a string. And remember, the string gets read from left to right, one symbol at a time. And as it reads each symbol one at a time, the automaton makes a decision which next state will it transition to from its current state. Right? Now, we started analysing this a bit last session, so I think we only, in terms of words, I got down to about here somewhere. So here's the full picture, and well, let's do it symbol by symbol and see whether this machine, this automaton, this computer, if you like, very simple computer, because it has a very small memory, whether it accepts this string. And can you remember what accept means? It means after the automaton, after it has read the last symbol in the string, so this right hand one, after it's read this final one, if the state that it's in is one of the accept states, and remember an accept state is diagrammed, represented by a double circle, and just a minute, it's cooler today. It's like the first non-hot summer day in months, and so I have not switched on the air conditioning, but I'm actually getting hot and sweaty, so just let me take a few seconds. I'll switch on the air conditioning and come back. Because an hour from now I'll be sweaty. I hate sweaty. Okay, so the double circle indicates that particular state is a member, in this case there is only one, member of the set of accept states. So if the final state, after reading the final symbol, if that state is an accept state, then this automaton is said to have accepted the whole string, right? Now, you can input different strings. You can have a whole set of strings. Now remember, a set of strings is defined, by definition, is defined as a language. Okay? So, an automaton, its function, if you like, is to accept or reject a language. So imagine all those different strings that get accepted by the automaton, put them in a set, right? And label that set A. Now a set of strings, by definition, is a language. So we can talk about language A, right? And then all those strings that are rejected by the automaton, and reject just means it doesn't accept, right? In other words, the final state after it's read the last symbol is one of these other states, right? Not an accept state. So it ends its final state, if we could use that term. So the final state then is not an accept state. And if that happens, the automaton is said to reject the input string. Okay? In this case, well, this one is accepted, but there are other strings not accepted. Now put all those strings that are not accepted, put them in a set, and label that set B. Okay? And every string in that set, B, is rejected, right, by this automaton. So in effect, the function, the job of an automaton is to recognize a language. Right? So this automaton recognizes language A, which that means all the strings that that it accepts, that this automaton accepts, right? So later sessions will formalize that a bit more in symbolic ways. So, but you know, I'm hoping it's becoming clearer now, or clear already, what the automaton does. Basically, it's a language recognizer. Right? To recognize the language means, saying it again, is that every input string in that language, in that set, is accepted by the automaton. And to accept a string means, reinforcement. To accept a string means that the final state, after you've read the last symbol in your string, that final state is one of the accept states. Okay? Right. Well, let's do it for this particular automaton. So M1, machine, first machine M1, this one, and this is our input string going in. And remember, it's read. It's read by the automaton from left to right. Okay? So it reads the first symbol, that's a 1, the second symbol is a 1, the third symbol is a 0, the fourth symbol is a 1. So it reads symbol by symbol, one at a time. And it reads a symbol and then it makes a decision. What's the next state that it should transition to, move to, change to. Okay? So that decision depends on two things. We did this last sessions. So the next state depends on the current state and the input symbol. Is it a 1 or a 0 in this case? Okay. And so the automaton has decision rules.